Hello everyone! In this lesson we are diving into the generation of point clouds from UAV images with Meshroom. In this tutorial I will explain how to use Meshroom to automatically create point clouds from a set of photos. After specifying system requirements and installation, I will give an overview of Meshroom interface and cover the basics by creating a project and starting the 3D reconstruction process. First of all, we will proceed with the download of the program, which can be found at the Alice Vision website. Alice Vision is a non-profit organization that creates Meshroom. On their website, in addition to download the program, we can see interesting information about the photogrammetric theory that makes the software work. This information is complementary to the theoretical video drone mapping photogrammetry based on unmanned aerial vehicles, so I recommend it. To download the software, click on the Meshroom tab and download the version you need, either for Windows or Linux. This practice will be performed under a Windows operating system. As you can read here, to fully use Meshroom, a NVIDIA CUDA-enabled GPU is recommended. Without a support NVIDIA GPU, only draft meshing can be used for 3D reconstruction. Once it has been downloaded, we can unzip the file wherever we want and start Meshroom directly, since it is a portable. We can extract it, for example, in the desktop. Next, we will start Meshroom. Meshroom has been conceived to address two main uses. Easily obtain a 3D model from multiple images with minimal user action, and provide advanced users with a solution that can be modified to suit different needs. For this reason, Meshroom relies on a nodal system which exposes all the photogrammetry pipeline steps as nodes with different parameters. The high-level interface about this allows anyone to use Meshroom without the need to modify anything, although in this tutorial we will modify some slight aspects to obtain the highest density point cloud possible. In the file attached to this exercise you can find the images taken by UAV, from which we are going to generate the point cloud. These images were taken in an agricultural industrial area in the town of Sagunto, Valencia, Spain. So we are going to load the images and we only have to drag and drop them. In this screen it is possible to view the images and play a bit with them. You can zoom in, zoom out, etc. After that we are going to save the project. Also in the desktop, and you can type the name that you want. Next, we will see the process node by node. The first node, called camera init, describes our dataset. The information about what these nodes do can be viewed in the documentation tab. It's here. In this tab, we can see all the description of this node. Also, it is possible to change its attributes, and during the execution of the program we can view the log. Finally, after the execution, we can see the statistics and the status. After that, we are going to edit the most relevant nodes in the process of creating the point cloud. The first one is the feature extraction. We are going to click on attributes and we are going to modify the describers. If we place the mouse on this description, we can see as the describer is the control of the describer density, and we can modify it from low to ultra. And it informs us that ultra is just for small datasets. As our dataset is very small, we are going to modify these parameters, the describer density and the describer quality, to ultra, both of them. In the verbose, we modify it from info to trace. In that way, during the execution of the program, we will have more information. Next, in the depth map, we are going to modify also the downscale. The downscale is the input images to compute the depth map. Full resolution is downscale 1, which give us the best result, so we are going to choose 1. Also in the node meshing, we are going to modify the max input points and the max points to the maximum. Also here we have to check this parameter, the colorized output, in order to have colors in our point cloud. In this practice, the mesh filtering and texturing nodes are eliminated, since we don't want to create a 3D model. If your objective is to obtain a 3D model, just leave them. Finally, we are going to create a convert SFM format and connect the input. We just have to press right button here and write convert SFM format. In that way, a node is created, and we have to connect this dense SFM data with our input. Here we have to select SFM file format that we want, that in our case is PLI, and the describer as unknown. We execute and we see how the log of each node shows different information. After the final of the processing, we can find in the folder of our project all the results that the software created. The most important for our tutorial is it can be found here in the folder convert SFM format. And here in this folder we can find the point cloud that create the software. We are going to open it with Cloud Compare. Just click Apply All, and here we can find the point cloud that we create. If you are interested in this software, you can find much more information and utilities in its manual that you can find here in internet. And with this we end this practice. Thank you so much for your attention.